Hello children. In the last video, we saw till this. Right now we'll start from here. Okay. So what was our main conclusion? There are three radioactive radiations generally that are produced. One is alpha, other one is beta, and the third one is gamma. Alpha is positively charged, so it is attracted towards a negative plate, and then beta is negatively charged, so it is attracted towards the positive plate. This is an electric field. You provided an electric field by having a negative plate and a positive plate, and alpha will be attracted towards the negative, beta towards the positive, and gamma will go undeviated. It will go straight. Okay. And another observation I told you to see is that beta will bend more. Okay, beta particles are deviated more than alpha particles. This is also an important conclusion that you need to know. So please mark these two conclusions. Those which turn towards the negative plate are the positively charged alpha particles. This is the conclusion number 1. Okay, and those that turn towards the positive plate are negatively charged beta particle. This is one of the conclusion. Then the second conclusion, and the one that pass undeviated, gamma radiation. And then the second important conclusion is beta particles are deviated more than alpha particles. Beta will bend more than alpha. Next topic is we are going to see about properties of alpha, beta and gamma radiations. Properties of alpha, beta and gamma radiations. Okay, there is one full page. There are two full pages of properties, but not everything is important. I'll just tell you how to remember. First of all, you're going to study about alpha particle. Now, what is the nature of alpha particle? How does it look like? One thing is, we said it's positively charged. Okay, but they have found that an alpha particle contains 2 protons and 2 neutrons. 2 protons and 2 neutrons. That means alpha particle's atomic number will be, mass number will be 4 and atomic number will be 2. Mass number will be 4 because it has 2 protons and 2 neutrons. Mass number 4 and atomic number 2. Okay, and if I have to represent it, it will be alpha 4 2. Okay, alpha 4 2. This is the mass number and this is the atomic number. This is the nature of an alpha particle. Okay, but for explanation's sake, they said it resembles. Okay, it is not. It is the same as a doubly ionized helium atom. Okay, you all know that helium nucleus has 2 protons, 2 neutrons and 2 electrons. If it is a doubly ionized, means these 2 electrons have gone. So even that will have 2 proton and 2 neutron. So alpha particle also is similar to a doubly ionized helium nucleus. So sometimes alpha, they can even write it as helium 42, but it is not helium. It resembles helium nucleus. So you can represent it like this. Okay, so that is the nature. That is very important. Okay, then there are so many points and there is a comparison table. I will tell you exactly what you have to study from that. Okay, now coming to the beta particle. What is the nature of beta particle? We know that it is negatively charged. Okay, they are basically fast moving electrons emitted from the nucleus. Fast moving electrons emitted from the nucleus. Okay, so where did electron come inside the nucleus? You know that electrons only revolve around the nucleus. Now that is what happens during beta emission. So if a neutron inside, so these emissions generally happen when the number of neutrons is more than number of protons. So the neutron might disintegrate to a proton. Because there are more neutrons, some of them might disintegrate. When it disintegrates to a proton, it emits an electron. Now this comes out as beta particle. Can you understand? Otherwise, there is no source of electron inside a nucleus. This only happens when a neutron changes to proton. It emits an electron, and that comes out as beta particle. Okay, so what will be the, how will you represent beta? beta 0 minus 1, mass number 0, atomic number minus 1, or E 0 minus 1. Is it clear, children? So for alpha particle, we represented it by, so it has 2 proton, 2 neutrons, so alpha 4 2 or helium 4 2. Okay, beta particle, it's basically a fast moving electron. That means its mass number will be 0, its atomic number will be 1 minus 1. So either you can write like that, or it's basically electrons structure. So E0 minus 1 also can be written. Gamma particle, now as you know, this is uncharged, so it will not have any electrons, protons or something. It is just an electromagnetic radiation. You can just underline here. Gamma radiations are the electromagnetic waves like X-rays and light, but they differ from X-rays, that we'll see later. They're basically electromagnetic waves, so they don't have protons or neutrons. Okay, now turn to this comparison given in the next page. Okay, so this table is a comparison between alpha, beta and gamma. Okay, so there are so many points, but the very important ones I'm marking, you study that, that is enough. First is the nature that I've explained already. Alpha particle is basically stream of positively charged particle, that is, it resembles helium nucleus. Beta, stream of negatively charged particles, that is energetic electrons. And the third one, highly energetic electromagnetic radiation. Okay, then come straight to the seventh one, effect of electric and magnetic field. So you know that alpha particles are less deflected, okay, and beta particles are more deflected, and you can say this is deflected towards negative plate, this is deflected towards the positive plate, and this is unaffected. Coming to the ionizing power, so you know what is ionizing power? Yeah, you've studied in chemistry. So maximum, alpha has maximum and beta has less than alpha, and gamma has the minimum. Even ionization or ionizing powers definition is given here. When an energetic particle suffers collision with an atom, it knocks out an electron, which now, so this is called as ionization. So alpha's ionizing power is maximum, beta's is less than alpha, and gamma's is minimum. Now there's another thing called penetrating power. Now, how much it can penetrate inside a material, how far it can go. Now that is opposite to ionizing power. Now here alpha had maximum, less than alpha, and minimum. Here it is the opposite. Penetrating power of alpha is very small. It can only penetrate through 3 to 8 centimeter of air. You can remember this also. Then penetrating power for beta is large, up to few meters in air. And then for gamma, it's very large, up to a few 100 meters in air. Okay, children. So the question that can come is, compare the ionizing power of alpha, beta and gamma. Or another question, another form of questioning is, arrange alpha, beta and gamma in ascending order of their ionizing power and penetrating power. Ascending order means increasing order. So ionizing power, so gamma is minimum, followed by beta, then alpha. So gamma, beta and alpha. Whereas for penetrating power, it will be alpha, beta, gamma. So these are the ways questions can be asked from this. Then come to stopping substance. This can be stopped even by a thin paper or human skin. This can be stopped by 1 millimeter thick lead or 5 millimeter thick aluminium. And for gamma radiation, you need a 30 centimeter thick lead sheet. You can imagine 30 centimeter thick lead sheet means it will be a really thick one. Then only you can stop it, or a few meter thick concrete. And these are the most dangerous ones. Gamma, immense damage. Okay, alpha, less damage. Beta, little more than alpha, and gamma, immense damage. It can cause lots of damage. Okay. So if you study these points, whichever I have tick marked, that's enough, children. Now we go to the next topic, changes within the nucleus in alpha, beta and gamma emission. What actually happens when alpha, beta, gamma emission happens? Let's go one by one. Let's start with alpha. Now, whenever alpha emission happens, okay, we'll see about alpha particle. Suppose, let's take there was X is a parent nuclei. Yeah. X was a nucleus, okay, whose mass number was A and atomic number was Z. I'm just assuming, okay. X is any nucleus, it can be anything, uranium, thorium, barium, whatever it is, but I'm just taking generally an X as an element, and its mass number is A and atomic number is Z. And if it emits an alpha particle, what will happen? How will its nuclear structure change? That is what you have to see. Okay, if it is going to emit an alpha particle, so alpha 4 2, you know that if it has to emit an alpha particle, means its alpha particle will have 2 protons, 2 neutrons, that is mass number 4, atomic number 2. So this nuclei will change to a new nuclei. It won't be X anymore because it has lost 2 protons and 2 neutrons. So definitely its atomic structure has changed. So it will become a new nucleus. Let me take it as Y, whose mass number will be A minus 4, because 4 has gone here. So A minus 4, and atomic number Z minus 2, because 2 electrons are gone here. So this will be Z minus 2. Now this is called parent nuclei and this is called daughter nuclei. Okay, so this is what will happen during an alpha emission. Okay, the parent nuclei will change into another one, and it's another nuclei, daughter nuclei, whose atomic mass number decreases by 4, atomic number decreases by 2. Okay, so let us start with alpha emission. Okay, so as usual, I told you condition will be whenever there are more neutrons than number of protons, it may emit a alpha particle which has 2 protons and 2 neutrons tightly bound together, known as alpha particle. Okay, so thus due to emission of alpha particle, atomic number decreases by 2 units, mass number decreases by 4 units. Okay, so this is called the parent nuclei and this is called the daughter nuclei. Then they have given one example, uranium 23892. Okay, this is a general one. This is a specific example, uranium 23892. Suppose if it emits an alpha particle. Okay, so you write alpha first because that's a sure one, and then this new element, okay, we'll see the element later, its mass number should reduce by 4, that is 234. 238 minus 4, 234. 92 minus 2, that will be 90. So if you see in your periodic table, this will be the atomic structure of thorium. Okay, so uranium was the parent nuclei whose mass number 238, atomic number 92, and then it disintegrated to form thorium of mass number 234 and atomic number 90, along with the emission of an alpha particle. Hope you understood, children. So this is what will happen in an alpha emission. Okay, now let's go to beta emission. Okay, same. When an unstable nucleus contains neutrons more than the protons, a neutron may change into a proton by emitting an electron for charge conservation. This electron coming out is called as beta particle. I had explained before itself. So what happens during a beta particle is one neutron inside the nucleus. Okay, because there are more number of neutrons when compared to the protons, the neutron will try to become a proton, okay, by emitting an electron. By emitting an electron. So proton, proton will have sorry children, neutron will be represented by 1 0. It will not have any electron. So its mass number is 1, atomic number 0. Then it will change to proton, whose mass number is 1, atomic number is 1, plus an electron. Now this electron comes out as beta particle. Basically this electron only comes out as beta particle. Okay, neutron changes, it disintegrates into a proton plus a beta particle. Okay, again let's take one specific example. Now let's underline few things. In other words, by emission of beta particle, mass number does not change, but atomic number decreases by 1. Now if you compare these two elements, okay, these two, their mass number is same. This parent nuclei, the daughter nuclei will also have same mass number as that of the parent nuclei. Daughter nuclei, parent nuclei, their mass numbers will be same, but only the atomic numbers will be different. What are they called? Substances having same mass number but different atomic number, they are called isobars. So when a beta emission takes place, this parent nuclei and the daughter nuclei will be isobars. They will be isobars. Okay. Now let's see an example, then we'll understand. By emission of beta particle, mass number does not change, but atomic number is increased by 1. It changes to a new nucleus with properties similar to those in element 1 place higher in the periodic table. The daughter nucleus, daughter product is thus an isobar of the parent atom. Okay, so generally, so this is what happens. Let us write it with respect to a general nucleus X. Okay, with mass number A, atomic number Z. So don't take this as parent and daughter. This is the parent nuclei. Okay, so it emitted a beta particle. So beta 0 minus 1, it's for sure. And then what will happen to the daughter nuclei? Its mass number will remain the same because beta's mass number is 0. So there won't be any change. A minus 0, again A, Z minus of minus 1. Okay, see the conservation, law of conservation of charges should be maintained here. Okay, so here if you add these two atomic numbers, mass numbers, that should be equal to this mass number. If you add these two atomic numbers, it should be equal to these two. So what should I do? So this minus this. So already there is a minus, so it will become Z plus 1. Hope do you understand, children? Okay, in the left hand side, total atomic number is Z. On the right hand side, to get it as Z, okay, I have to put plus 1. Then only when I add these two together, Z plus 1 minus 1, I'll get as Z and they will be balanced. Is it clear? So this is the beta particle. This is how it will look. And X and Y both will be isobars. X and Y will be isobars. Let's see one example. Okay, one example, carbon. Okay, one practical example. This is a general one, this is an example, same way. Carbon, okay, carbon 14-6, okay, when it emits a beta particle, okay, so this new nucleus should have mass number 14 and atomic number 7, 6 minus of minus 1, 7. So that will be nitrogen. That will be nitrogen. So carbon 14-6 got disintegrated after emitting a beta particle, got disintegrated to nitrogen. So these two are isobars. Hope it's clear, children. So this is how, and beta, this is what will happen during a beta emission. Now gamma is very simple, so you have to please put a tick mark near these examples, general one and then the example. Similarly here, this is what actually happens, and then the general equation, then the specific equation. Coming to gamma radiation, okay, usually generally with after an alpha or a beta emission happens, this nucleus, suppose you take this reaction, uranium changing into thorium by emitting an alpha particle. After emitting this alpha particle, this will be in an excited state. This will be in an excited state. So immediately it will also emit a gamma radiation, emit some gamma radiation. Same way here also. So that is the conclusion. In many cases, an alpha or beta emission is found to be followed by a gamma emission. It occurs when the daughter nuclei is in a state of excitation. That is, it has an excess of energy, and this extra energy is released in the form of electromagnetic radiation known as gamma radiation. So you know that it doesn't have any electric charge, so it is just a wave. So if I have to represent a gamma radiation, I just have to, the parent nuclei, I have to show the star thing showing that it's in an excited state, and after emitting a gamma, the star thing will go off, it comes to the normal state. So parent nuclei, daughter nuclei plus gamma radiation without any change in mass number and atomic number. Is it clear, children? So then this note I want you to, you have to underline this. There are three important conclusions. Okay, electron emitted by beta does not exist in the nucleus. It is created, so I told you already, it is created during a beta emission and then it just comes out, it doesn't stay inside. Second one, in a single radioactive decay, alpha and beta particle are never emitted simultaneously. They will never be emitted together, alpha and beta. No, it's either alpha or beta. Okay, there will be either an alpha emission or a beta accompanied by the gamma emission. Then the third conclusion is the daughter product formed after the emission of either alpha or beta may again be radioactive. This, the daughter nuclei formed, this again will be radioactive, and this can emit again of alpha or a beta nuclei. That is also possible. This can emit something else also. So usually this keeps going on. This keeps going on. So the daughter product formed may again be radioactive, and it may further decay by emitting either alpha and beta. This process continues till a stable nucleus is formed. And as a conclusion, they have given this table, what happens in alpha, beta and gamma. Z decreases by 2, increases by 1, no change. And mass number decreases by 4, no change, no change. I hope this is clear. And the homework for today will be, children, write the answers for page 298 to 99. So you have to write the answers for 19, 22 and 29. Question number 19, 22 and 29. Thank you, children.